To understand what the cost index is, it's important to know a bit about airline operating costs. An airline operating cost is usually given as a cost per hour. How much does it cost per hour to operate a Boeing 777? How much per hour to operate a Dash 8? And so on. Operating costs can include things like crew salaries, the cost of leasing the aircraft, if that applies, landing charges, overflight fees, maintenance costs, airport services like ground handling and customer services. But for the purposes of calculating the cost index, only the costs that are truly time-related, such as crew salaries and maintenance costs, are used. And there is one other significant cost, and that is fuel. The cost index is simply the ratio of the time-related costs and the cost of fuel. The aircraft's flight management computer optimizes a flight based on the cost index value that is inputted. The cost index values can range from 0 to 99. Aircraft operator figures for their cost index are typically between 20 and 40. To work out the cost index, you divide the time-related operating costs by the fuel costs. Time-related operating costs are quoted as US dollars per hour and fuel costs in cents per pound. As an example, let's assume that the time-related cost for a flight is $375 US per hour, and the fuel cost is $545 US per ton, which amounts to about 25 cents per pound. You divide the time-related cost by the fuel cost to get a cost index of 15. Bear in mind that operating costs, such as salaries and maintenance contracts, don't change that much over time. But the cost of fuel can change quickly and by significant amounts, even during the same day, depending on which airport the aircraft is refueling at. So, as the fuel price changes, so does the cost index. The flight crew is given the cost index figure by flight operations. They input this figure into the FMS, and it automatically calculates the optimum speeds the aircraft should be flown at for the climb, en route, and descent. With a low cost index figure, the cost of fuel is high, but the time costs are low, and as a result, the aircraft is flown at lower climb speeds, which means that the aircraft will climb at a higher rate due to the excess engine thrust, lower cruise speeds, and normally higher altitudes, so that the fuel burn is reduced as much as possible. With a higher cost index, the time costs are high, but the fuel price is low, which is rare these days. As a result, the plane will be flown at high speeds to minimize the time. Of course, since the aircraft will fly faster, it will burn more fuel, and the aircraft's rate of climb will be lower because most of the engine thrust is being used to maintain the higher speed. With a lower cost index, the aircraft's top of descent is early because they're descending at a lower speed, which also means a lower descent rate. With a higher cost index, the top of descent will be later, and it will be at a higher rate of descent and higher speed.